My biggest inspiration has to be having worked with my grandfather and my uncles. And I remember waiting for the adobe to cure and then finally, stacking bricks to form the walls of the house.
And I always liked being creative. I love math and mechanics. But perhaps when I was young, I didn't know that I was part of engineering.
My father is a civil engineer. I was very proud when we walked in our city. My father, he designed this building, he designed that building. So I wanted to be an engineer.
In a broad sense, engineers apply scientific and mathematical principles to everyday problems.
I think that above all, engineers are problem solvers.
With your work, you can improve the quality of life that will make our society and the life of many people much better and safer.
An engineer is somebody who's really looking to design something to improve society.
What we try to do is to provide students with the tools so that they could be innovative in their solutions to the problems that they're going to be dealing with every day.
And so as an engineer, we like to break things and put them together.
When we look at the state of the infrastructure today, it's not doing well. And so we're looking to create ways to improve our durability and sustainability of those structures.
The bridge inspection program started in the late 60s, early 70s. This program initiated as an inspection program where students focus mainly on routine inspection of bridges. Many of the bridges that we inspect on a day-to-day basis are over 50 years old.
And the lifespan of a normal bridge right now is about 50 to 75 years.
And our program, well, we employ co-op undergraduate students to work under a professional engineer in the routine inspection of bridges owned and operated in the state of New Mexico.
So when we're on a bridge inspecting it, you just go out there and you're looking for any type of flaw that may be causing an issue. One of my research projects right now is on ultra high performance concrete that has compressive strengths about 5 times what we typically see. But the high performance comes from the durability properties of it. There are a lot of proprietary mixes out there. We're looking at using materials that are readily available in New Mexico. Not only can we use it for new construction, but to go out and repair and rehabilitate bridges that have some issues. We're hoping to extend that life cycle to about 125 to 150 years.
Geotechnical engineers or soil mechanics, the study of specifically soils and how soils behave, and that's how we're different from, say, structural or hydraulic engineers. We're still are motivated by the same basic needs and problems, which is solving basic human necessities.
The Engineering Center for Biomediated Bioinspired Geotechniques, or CBBG, is an engineering research center sponsored by the National Science Foundation. The biomediated processes, for example, using processes that are in nature that we can emulate or use to solve engineering problems.
One example that is easy to see is a tree. If you take a look at a tree, it's a very slender structure from an engineering standpoint that is subjected to very strong lateral loads. And so root system allows trees to stand in the wind and not fall apart. An analogous problem in the geotechnical side would be the foundation of a windmill or a wind tower. The problem we have is that now we have very strong lateral loads on very slender structures. And the way we solve the problem is by over-designing the foundations and by having very deep, expensive foundations. So the idea there is to take a look at root tree systems to come up with a better design for the foundation of a windmill.
We are learning from worms. They have that ability with very little energy to penetrate into the ground. The goal is to produce a probe or an instrument that will self-propel into the ground, and we can then instrument such a probe to actually gather information of the engineering properties of the soil.
Polymer bonded sands, it's a project that is funded by NSF. The way we typically modify the mechanical properties of soils is by cementation. And what it does is it gives soil tensile strength, which they naturally do not have. The problem with that is it becomes very expensive very quickly. In looking at alternatives for cementation, we came across polymers. Polymers or plastics are very common today. So common, in fact, that we dispose of millions of tons every year in the US alone. So the idea is how can we use these polymers to change the properties of soils? And the idea is really simple. If you grind these polymers and turn them into a powder, you mix them with the soil and you heat it up, the polymer melts and starts to coat the particles, and then when you take the heat out, it solidifies and it renders the whole thing cemented. So you create a block, for instance. And that block has properties that are very, very neat and that could help us solve many problems in ground improvement.
Renew it basically it's a reinventing nation's urban water infrastructure. So the idea of reinventing, we're looking at innovative ways to improve, build this infrastructure and get away from this centralized system.
In general, people think about wastewater is dirty water, and it has different contaminants in it. But wastewater can be also a resource. It depends on how we want to use it. We are running out of our fresh water, surface water, groundwater, and then wastewater can be an alternative water supply. For example, we can use the wastewater for agricultural irrigation, for the landscape irrigation, for golf course irrigation. We can even treat that water for drinking water.
The site we're talking about is by the river. It's at Salon Park. It's surrounded by housing areas. What we're doing there is using natural system by bringing in native vegetation like salt grass, which can withstand brackish water, and we use that to stabilize the embankment. And the idea is you want diversity of wildlife. In addition to that, we are improving the ecology. So that means we want diversity of plants so that it can support insects, birds, wildlife.
But we know there are different contaminants in that wastewater. So how can we remove these contaminants, purify the water to meet different application and water quality requirements? Depending on the technology, when we remove salt from the water, we also remove other contaminants from the water as well. El Paso desalination plant, this is a 27 million gallons per day treatment facility. It uses the reverse osmosis technologies, so we get the desalinated water. It also generates 3 million gallons per day of wastewater.
The department is truly a great place to work. The faculty in the department come from all over the world.
We have faculty with very diverse backgrounds.
Here, the professors value teaching. Every faculty is a great teacher.
I enjoy the research we're doing. I enjoy the collegiality of everything. And I enjoy working with the students.
The students participate in the design of the experiments, in the formulation of the objective of their research.
The best part of being here has to be, I truly feel that I see myself in the students that come here to NMSU.
Geotechnical engineering allows us to be very creative with the solutions and our design, and I like that.
Environmental engineering is a very, very important area for our whole planet because we only have one Earth. We have to protect our planet.
Bridges, they keep getting bigger and longer. They're landmark structures. I mean, you can actually go out and touch them and say, I built this. I think that's really awesome.